Hey everybody, thank you so much for joining us today for a webinar with Point One Navigation and ST Microelectronics. Really appreciate you making the time. We're really excited to talk about precision navigation for your outdoor robotics, specifically your lawnmowers and turf management systems. Please let us know where you're joining in from in the chat. We'd love to hear where people are coming in from today. And we're going to just wait a minute or two for folks to join. So just let me know where you're joining in from. Really nice to hear where everyone is calling in from, and we're going to get started very shortly. Just also an FYI, we'll have a question and answer after the presentation. So please ask questions in the Q&A, and we'll make sure we get to them after the presentation. Okay, I'm going to let Max, Gabe, and David take it away from here. So please enjoy.
Hi, everyone. My name is Gabe Amancio from Point One Navigation. I lead our application engineering team here. Been with the team for over 3 years, working across a lot of different applications, specifically focused on our RTK service and the other side of our business being our positioning engine. But I'm going to hand it off to my colleague, David.
Hi, everyone. My name is David Fang. I'm part of the field applications engineering team here at Point One. I've been here about 1 year, but I've been in the GNSS space for quite a few years, both on the hardware side as well as correction side. We've seen a lot of interest and pickup in the robotics and especially in the mower space, so I'm really excited here to talk to you guys. Max?
Thank you, David. Hello, everyone, and thank you for attending this webinar. My name is Max Nicotra. I'm Market Development Engineer for ST Teseo GNSS Chips and Module Solutions. I'm very pleased to participate in this webinar with Dave and Gabe from Point One Nav and have the opportunity to discuss ST and Point One Nav's best-in-class joint precise positioning solution. STMicroelectronics is a global leader in the semiconductor industry, providing innovative solutions for various applications, including automotive, industrial, and consumer, with a strong focus on research and development. STMicroelectronics delivers cutting-edge technology and empower its customer to create products that improve everyday life. The products listed here are just some that directly support autonomous mowing. ST Teseo GNSS receivers are crucial for enabling precise positioning in automotive, industrial, and consumer applications due to their high performance and advanced features. STM32 microcontrollers and microprocessors are high performance, low power devices designed for a wide range of applications. These devices are based on the ARM Cortex architecture and offer a comprehensive set of features, including advanced peripherals, integrated memory, and robust security options. STM32 microcontrollers are ideal for embedded systems, while STM32 microprocessors are suited for applications requiring higher computational power and connectivity. Microcontrollers sold under the name Stellar and STM32A are ideal for automotive applications requiring high performance, robust reliability, and advanced safety features and scalability. ST is a leading provider of MEMS sensors, which are designed to deliver high performance, reliability, and energy safety efficiency, making them ideal for automotive, industrial, consumer, and healthcare markets. There are other products mentioned here, and more are available on the ST website. So I highly recommend you visit www.st.com to learn more about ST products.
Thank you, Max. I appreciate the intro of ST Micro and the partnership that we've created here. And just an intro on Point One Navigation. We really are a platform for precise location wherever you're at in the world, kind of via two different products. One being our global RTK service, which comes in different flavors that you see here. True RTK, which is network RTK from real base stations. We have about somewhere over 2,500 base stations now worldwide. And then our virtual service, which is an SSR-based solution, which enables consistent coverage independent of your baseline distance to an actual base station. And the other side of our business, which is where we partner very well with ST and their chipset, is the embedded positioning engine, which basically takes in those RTK corrections, GNSS observables, and fuses in other data like IMUs, wheels, sensors, camera, LiDAR, to enable positioning even when GNSS is not available. So you can see there the dead reckoning is a big portion of that, and enables positioning, like I mentioned, outside of GNSS. What we'll be talking to today is really the enablement of autonomy in mowing in the industry. There's an explosion of use cases which are listed here, but I'm going to just kind of quickly go over the big ones we've seen, one being consumer lawn mowers that run autonomously, and then another that's more of an industrial grade mower, which you can kind of see on the right here, which are typically used in like golf courses or large fields to maintain consistent mowing autonomously in these environments. And what you see is really real business benefits from moving towards autonomy in mowing. I'll kind of quickly go through these here, but one being off-peak / night operation. So then when people are actually out using these areas, you don't see these mowers out and about. The next being reduced staffing. Again, these run autonomously, so there's a need for people to actually work and understand that portion of it. But again, these mowers are going out on their own and doing everything that needs to be done. Improved operator safety. So having this centimeter level precision obviously enables a lot of things on the safety side. One being around the actual human interaction with these devices and having that capability to have knowing exactly where these are at. And then on the other side for building out like specific routes that these mowers are going on, you'll never have like the fear of like losing track of where that is or having that interact with people around. More frequent mowing. Again, these run fairly consistently. Not really like a traditional mower where you're going out say like every week or so to do this. These are constantly running, like you can imagine like a Roomba where they're cutting the lawn very consistently. And then consistent precision for some of those industrial cases. It's very important to have very consistent length of cutting. So that's really what we're seeing here.
Yeah, Gabe, that was awesome. Like all the stuff you were bringing up. Maybe one thing I wanted to add to this is some of our mower audience in the mower space may be using local RTK stations right now, where they ship a physical base station with their mower. Um, I'm sure those people have experienced a lot of pain supporting those customers and setting those up in the right environment where it's open skies. And it's another piece of hardware that, needs to be created and built and tested and then shipped out to consumer. It's an expensive piece of equipment. If it breaks or fails, you have to replace it. That's something where network RTK and point one can really solve that for this kind of use case where we can take that whole hardware piece out. You could just get the corrections from us, get that centimeter position mowing right out of the box without setting up additional hardware. And when we think about, all the easiest to use products we have in our lives, the best ones are all ones you could just open up the box, turn them on, and get started using right away. Point One's not just an end trip and corrections provider. We provide tools in the back end so that the OEMs, such as yourselves, can build the tools for the customer so that right when they take that mower out of the box, they're ready to go. They have the apps ready, all the back end stuff set up. They can just set up that mower in their yard and turn it on, say go, and everything's done. Point One can really help with that. Point One, again, provides a little bit more than just a correction service. I think most people are familiar with using Ntrip to get corrections from a corrections provider. We do more than that. We have a really nice API that allows the OEMs, such as ourselves, to manufacture a mower and also provision that mower all at the factory. You can communicate with our API to tag mowers so you know which device goes to which mower, get the credentials out of that, place those on a mower before you package it up, test it all out, When that mower gets to your consumer, your end user, whether it's commercial or a consumer product, it's ready to go. Makes it really easy for you guys to build apps to provision the mowers at the factory, get things tested, and make sure everything's working before that mower gets out to the consumers.
Awesome. So I'm going to kind of talk through some of the benefits that we see from this full end-to-end solution. So the one that David really just mentioned is the business workflow integration at scale. So as many of you are probably familiar, as David mentioned, with the typical path of like setting up an Ntrip client, and traditionally there isn't a super easy way to programmatically do that. There are ways where you can have like a universal username password, which then enables things like security risks that you may be aware of as well. But what we really enable with that API is RTK credential pre-provisioning. And what that means is basically enabling the end user to pre-provision all of their devices with these credentials. So that when it actually gets in the field and you need to enable them, nothing needs to be done from the end user's perspective to actually input that, which just makes it at the end of the day a lot easier for the end user who may have no knowledge about RTK or anything like this to just kind of get up and running out of the box. The other piece that's really important to this as well, so there's device provisioning and actually getting those credentials to your own device. And then alongside that, we have a license management system, which kind of enables, I would say, like two different things. One that you can imagine is, like I said, the end-to-end live factory testing. So for instance, you can have a license type that is specifically like a factory license. And with that, you can basically assign that to a specific device when it's in the factory. It can have like 1 day of an entitlement. So you can basically send it out, make sure that it's receiving corrections, the full end-to-end flow works. And then that license isn't, is then not disabled, but automatically ends after the factory testing is done. And then when the end user gets the device and turns it on, this also enables what we call like technically you can have multiple year or 1 year kind of licenses. But since you have that visibility of the end device, when it turns on, you can programmatically grab that device ID, assign it a 1 year, a 3 year, a 5 year license, depending on what the terms are. And then that end device just works out of the box. There's no need any longer for them to go on top of the roof and set up a base station that then needs to be surveyed in or have like not absolute location associated, more relative. So again, we want to make sure that the end customer doesn't feel that pain of the actual RTK setup or even having to worry about that.
Hey, Gabe, maybe one thing I wanted to add is that on the fleet monitoring side, that also provides an avenue for for the ODM to support the customers as well too, because they can then monitor where that mower is and what that mower is seeing from a satellite standpoint. So something that we feed back into the API is, how many, whether it's an RTK fixed or float or autonomous solution, and how many satellites it's seeing, and you can use that information to feedback to the customer on how well they're doing, how well that mower is doing, and what how they can improve as well too.
Yeah, that's a great point. It's really a helpful tool for debugging as like a first pass at like a lot of times for these local base stations, they'll call immediately and be like, why is my system not working? This enables you a way to really do that first step of debugging without actually interaction with the customer. Because a lot of times, like David mentioned, you can get the satellite count and you see 0 satellites. You can basically like set up a notification. It's like, hey, are you actually outside? Like, is that a real thing that's happening now? So that's a really good point. Kind of talked to this already, but true baseline RTK network. So for this specific application, there's a lot of services out there that are providing, SSR-based corrections, which enables a little less accuracy, but blanket coverage. We do offer that, but really our flagship product is our true RTK network RTK, which is real observable data in real time, which enables the centimeter level accuracy. The difficulty of that is having a ton of base stations, which we have already solved that problem. And we are continuing to expand our global coverage daily with this true baseline RTK with our own base stations. And we'll continue to guarantee that continental coverage and also global coverage. And really on the network side, we do have the complete cloud backend to basically enable from the network's perspective and from the device's perspective, complete visibility of both of those things. So whether that's having access, like David mentioned, to what's happening to a specific base station or what's happening to a specific device, we have this cloud backend with our API available to give you that level of information without us like obscuring that data or anything like that. You get all access to that, and that's just a feature of our network.
So we're going to talk a little bit about how does RTK help and why you need RTK. So uncorrected without RTK, you can get a GPS or GNSS solution that's about a couple meters in open skies. And the reason is because as the signals traverse the atmosphere from the satellite to your receiver, there's a number of errors. There's clock errors, orbits errors, atmospheric errors. There's multipath when a signal bounces off a building and come into your receiver. There's occlusion where you can't see the particular signal. And all these contribute to delays that causes the receiver to have issues creating a very accurate solution. So yeah, Gabe, how does RTK solve these things? How do our other technologies help in these cases with these errors?
Yeah, so first, kind of just talking through the GNSS side, because I think that's really what we want to focus on here is the RTK. A specific RTK base station, which I mentioned we have a ton over throughout the world, is basically seeing the same signals that the end device is also seeing. So what that really does is now we have a known absolute location of the base station. That data of what it's seeing in the sky is passed along to the end device, and then math is done to enable the centimeter level position. Obviously, the further you go away from a base station, the less the observables are valuable. But that's why we've really worked to make sure that we have base stations everywhere and enables that centimeter level accuracy everywhere. The other side is when you don't have GNSS available or occlusion or multipath. We provide a positioning engine that kind of solves for some of those issues. So one being multipath, we're able to basically tell, like we know where a satellite should be coming from. And the next second, if all of a sudden the satellite's coming from a different direction, we recognize that as multipath and throw out that data as bad. We don't want to use that in the solution because it may cause error. The other is, say you're have occlusion happening, whether it's just one side or full occlusion where you literally have no satellites. We start to incorporate other sensors like ST's IMUs, wheel speed sensors, camera, LiDAR, and certain other applications to enable you still positioning when you don't have GNSS available, and then gives you a trajectory for that position when you do actually get GNSS again. So one of the things that happens when you only have GNSS available is all of a sudden you can have huge jumps in your position when you start to lose the amount of signals that you're seeing in the sky. These other technologies enable you to actually still output a position and then basically reacquire that fix when you do have GPS or GNSS available again.
Yeah, and that's super awesome that our positioning engine can, fuse all these sensors together to create that solution. I just want to make a point as well too, why the TESIO6 is so powerful in these scenarios. We're talking about, golf courses can be quite wide open. But if you're talking about somebody's house, you can have a tree in random places, a pretty small yard. You have a house that could be, blocking some of the signals or having, causing these multipath issues. And the TESIO6, this latest generation, is able to track all the constellations. So GPS, GLONASS, Beto, Galileo, and can track all the signals. That just gives you way more availability and a way higher probability of being able to track signals and create a precise position. That's opposed to previous generations or older receivers that can only track two constellations or two signals, right? And that just helps a lot when you're partially occluded and not being able to see the entire sky.
Great point.
Okay, thanks, Gabe and David, for the useful explanation of why the RTK solution is so important to achieve a centimeter level accuracy. I think I can go first here and say how STM.1 help you to win. So we'll now introduce the first component of the winning formula, the Teseo GNSS receivers. ST offers a range of multi-band, multi-constellation GNSS receivers. The Teseo 6 family is the latest addition to the ST Teseo GNSS portfolio and improves upon the previous generation receivers, offering quad-band, quad-constellation chips and module solutions with safety, integrity, and security capability. I will delve deeper into the Teseo 6 family in the next slides.
Yeah. So on point one side, we're bringing you guys coverage wherever you guys need it, right? I think we're deploying something like 3 base stations a day, so we got a super dense network. You can see our coverage maps; they're all on our website. Feel free to go to point1nav.com to check that out. Again, on the true side, we have super dense, so single baseline network, which is really what lawnmowers require, centimeter, low centimeter precision. While we also have a virtual network that's more consistent across broader regions. Um, we're really helping you guys out on the API side to help you guys develop apps that are really going to make things easier. So when that consumer opens that lawnmower, everything's ready to go. They got an app ready, they got a mower ready. Everything's super easy to use.
Yeah, and what the Teseo 6 actually does, it provides a measurement to a host MCU where 0.1 RTK solution runs, and depending on the application at issue, the 0.1 amp RTK solution can run on a microcontroller such as STM32H7 or a microprocessor such as STM32MP1 or MP2. And the 0.1 amp RTK solution also supports that reckoning when an IMU is attached, and typically is a 3D accelerometer and 3D gyro.
Yeah, thank you, Max. That's
Yeah.
exactly right. We have a tunable fusion engine, which is our positioning engine that fuses RTK, inertials via IMU or wheel speed sensors. Typically in other applications too, we can support camera LiDAR, but this really enables kind of what we talked about before when you are occluded from GNSS, integrated dead reckoning. So having a consistent and accurate solution independent of if GPS is available, we want to make sure that we offer that. Also unique to us as well as we do tune this for different applications. So we do have some expertise across not only lawnmowers, but other applications like automotive, planes, drones, you name it. We have a team internally that works very hard to make sure that we tune for your specific application. And then to the integration and scale side on these last 3 points, we've kind of hit it hard, but our API really enables diagnostics, debugging for your customers as like a first step. And then at the end of like what we're providing via our positioning engine is this absolute position with variants. You get attitude solutions as well. And then you can really incorporate that into your own control system and then make decisions on how you want to operate these machines. Yeah, that is kind of what we as a team with STM.1 help you win. We give you this full end-to-end solution and make sure that whether it's from the hardware perspective, the software perspective, it all comes together to give you this accurate location.
Oh yeah. So as we said, the Teseo receiver is the foundation of the solution where everything is built on. So let's see why the Teseo 6 family. So the Teseo 6 is the first low-cost quad-band and quad-constellation automotive-grade GNSS chipset. It's 7x7 millimeter QFN 56 on the market, and is capable of operating up to 105 Celsius. It is robust, it's reliable, 2 megabyte PCM, which is integrated into the chip and simplifies and reduces the BOM cost. He has 96 data, 96 pilot channels for fast acquisition and tracking. The Teseo 6 is also, it can be employed as a positioning engine and measurement engine. He has added B2B, B3I, and E6 signals to increase the signal availability, resulting in reduced outliers in obscured environment. And also TSEO6 is capable of acquiring and tracking satellites using signals belonging to the L5 band, which is L5, E5, B2A at 1,976 megahertz without using the L1 band. This mechanism improves the anti-jamming capability.
And Max, I was just curious, what are some differences between the TSEO6 and, compared to some other receivers or older generation receivers?
So actually, the TSEO6 brings in other bands. As you can see, L1 and 2, L5 is 6B3I as in embedded flash, integrated flash, while the previous generation devices needed F2 SQI flash. And for sure, the independent L5 acquisition that helps to improve upon the anti-jamming solution. And yes, and the added B2B, B2I6 signals to improve the availability and to reduce the time to first fix in cold start, definitely.
Yeah, I think from the point one side, we've seen a lot of test data coming from our current mower customers that shows that having the extra constellations and bands really, really helps in the real world. There's some areas using some other providers where either the providers or their chipsets didn't have the requisite bands. They only had L1, L2, or just GPS and GLONASS. And having the newer constellations in Galileo and Beidou and L5, as well as L1, L2, really, really helps performance and provides way more opportunities for RTK fix.
Yeah, and David, that's a really good point. Even from the network's perspective, like you have to make sure that, obviously we're tracking that from the receiver's perspective. You need to be receiving that data from the base station as well. So making sure that the network data that you're receiving is also tracking all of these as well, right? There's no value to having there's value, but less value to non-corrected solutions. So say your base station only has L1, L2, but you're utilizing all quad band, you're losing a lot of valuable data there. So both from the ST side, which covers it very well, and point one, we want to make sure with our base stations that we're also covering all of our ends on that as well.
Right. Yeah, which we do. We have latest generation receivers on our end, so we can provide all constellations, all band support.
All bands. Definitely.
This slide depicts a top-level architecture of a precise positioning solution. The TSEO6 is a precise carrier phase-based measurement engine. It provides measurement to a host microcontroller or microprocessor that runs the 0.1 RTK positioning engine. The 0.1 RTK positioning engine also receives 0.1 corrections as input and calculates a precise position to support centimeter level applications. The RTK algorithm also support the DR, the dead reckoning algorithm, when the IMU ASM 330 LHH, as you can see here, is attached.
So Max, can you kind of describe how this block diagram is manifested in the ST portfolio in terms of the chipsets or modules that you have?
Sure. So if you take a look at the three blocks in the center of the slide, such as the TSEO6, which is a chipset, the TSEO6A module, the block says computation, the one relative to the MEMS, ASM 330LHH. If you take a look at this and you transition to the next slide, I will tell you the beauty of having the three blocks. Of course, the TSEO6 family also consists of the two modules, not only chipset. And LS6A is built on the TSEO6 chipset and encompasses the three blocks that I mentioned before. Integrates 2-arm Cortex M7, Core 0 to run the ST measurement engine, and Core 1 to run the 0.1 RTK position engine. It is, say, self-contained solution is ideal for reducing time to market by minimizing the development time, and especially for small development teams or low volume application. LS6A also integrates an AMU and to support the dead reckoning solution. On the right, you can see BIG6A. So when the applications require more computing power, running an application layer, managing a display, you might need an STM32MP1 or MP2, our microprocessors, running a Linux release. This is of the essence in that case. In this configuration, the BIG6A is a measurement engine, provides measurement to the microprocessor running the 0.1 RTKPE to achieve centimeter level accuracy. BIG6A is built on the SEO6 chipset and also integrates an AMU to support that reckoning solution.
Yeah, one question I had is what's the difference between MP1 and MP2, and when would I choose one over the other?
So MP2 is the latest addition to the microprocessor portfolio, has advanced features that improve upon MP1. Both valid microprocessor, of course, it depends on the application where they are going to run, and then you can pick either one or the other.
Maybe this question is for you, Gabe. Is there a difference between how point one deploys on an embedded PE versus the full PE?
So not specifically. So what you will actually be running on, if you can look at the ELE6 here, the intention and what we have today is a fully based inertial solution that utilizes all constellations, all signals. I guess, real benefit of having like an MP1 or MP2 from our perspective is there's more space to run. So I guess actually to your point, if you want a higher output rate, you will probably want to have something closer to like an MP1 or MP2 to support, say, like 100 hertz. But beyond that, the actual core algorithm is consistent, independent of its if it's on a microcontroller or a MP1, MP2, or integrated into the actual module on this core one that you see. So that's really the trade-off from our perspective. But you have that optionality when you work forward with ST and 0.1 on this solution. Yeah, thank you all for attending this webinar. You have here, if there's interest in testing with the ST chipset, our correction network, you can actually go to our website at www.point1nav.com, and there's a link there for you to sign up to our web app, get credentials immediately, and start testing on our network for free for 14 days. For anyone out there, specifically on the OEM side, that has interest, please reach out to us on that website as well. You can contact our sales team, and we will reach out accordingly. But yeah, thank you very much.
Thank you for your time today.
Thank you.
Okay, thank you so much to Max, Gabe, and David for that. I'm going to actually open up the floor for some Q&As that we got in. So if you guys are ready, we have a question from Kendra here, and she's asking, how close do you need to be to a base station for centimeter level accuracy?
Yeah, I can answer that. We, at least in terms of our network, are actively always trying to go to 40-kilometer coverage, based off the spec of the RPE and the receiver associated. It's typically 1 centimeter plus the distance to the base station times 1 part per million. So at 40 kilometers, that puts you at about like 4 centimeters in the two dimensions. And that's our goal, is to always make sure we're within that 40 kilometers. The closer you are, it gets you closer to that 1 centimeter, but that is our goal.
Awesome. Thanks, Gabe. Here's another question that just came in. Is every one of your true RTK base stations L1, L2, L5?
Yeah, I can answer that. Our base stations are manufactured in-house, and so they're capable of tracking all the latest constellations. So we mentioned in the webinar, GPS, Galileo, GLONASS, Vado, and does track L1, L2, and L5, and actually L6 as well too, although that's a little bit less useful in most cases.
Awesome. Thanks, David. I think this question is for you, Max. Would you please share the IMU specifications and PN you use in this specific system?
I think that the one used is the ISM 330LHH, which is the industrial version of the ASM that I mentioned before. I can even answer in the chat.
Thank you, Max. These are great questions. Thanks, everybody. Keep them coming in. Sean asks, can the module receive RTK corrections data from satellite instead of internet?
So I can answer that one. Us at Point One, we do support certain customers now on satellite corrections. Something that we do support, but for this application specifically, you do get less accuracy associated. Those corrections, satellite or L-band based corrections, typically are based off the SSR based corrections, which we discussed previously for virtual RTK. So it can give you closer to like 10 centimeters, which for certain applications that can be fine. When precision is really required, though, we would recommend at least prioritizing true RTK. We see some applications where it's good to actually have redundancy of both of those in the case of loss of cellular or something like this. But yeah, for at least this use case, typically we recommend having that high level of accuracy.
Yeah, maybe to add on to that, definitely in a mower case, it could be difficult, right? Like, yeah, you need to have a L-band capable receiver that's has line of sight to a geosynchronous satellite where the satellite corrections are being delivered from. So it's a different hardware setup as well on the mower side. So there's quite a few pieces in play, but the short answer is yes.
Awesome. This question is in relation to some of the errors that we showed on that map with precision. How does geofence setup get set up? How does the geofencing get set up to have that same centimeter level accuracy?
Yeah, so the geofencing is something that would be built in by the OEM. So it's something that could be built in the app. And the way to imagine it is if I have a lawn and you have a satellite photo of my lawn, then the user could just take their app and draw where they want to mow and exclude the portions they don't want to be mowed, whether it's like flower bed or sidewalk, whatever it is. And RTK just really helps in this case because of the centimeter accuracy. It helps your robot and your mower to stay on that geofenced area, right? And that's where it can really come into play. With the autonomous solution, if you're like a meter off, you're now mowing onto a sidewalk, you're mowing into your mulch or something like that. So that's something that the geofencing is something that's really enabled by using RTK.
Yeah, and I think to that point as well that like we are really STN.1 are enabling giving you that data in terms of precise positioning, and then you guys have the ability to then build features like that, like the geofencing, like the control system to like understand, okay, in this specific environment, I don't have good GNSS availability. Maybe I want to rely more on different sensors to that point. Things like that, attitude solution, which then you can incorporate into your solution. But at the end of the day, we just want to make sure that we're providing you that precise location.
Awesome. Thank you guys so much. I guess we have time for just one more question. With RTK, is AGPS or PGPS still offering some sort of benefit?
So yes, AGPS will, well, I guess kind of.
Yeah.
With our service, we actually also provide ephemeris data in our data stream or in a separate data stream via one of our mount points. So in that case, no, because basically what you would be getting provided would be covered when the ephemeris and the RTK data that we're providing. But if you don't have those available, it does provide, acquiring a fix quicker, not necessarily on the accuracy piece. You're not going to see any benefit.
Awesome. Thanks for that, Gabe. I know there's a few more questions in the chat. Please feel free to reach out to us. Our contact info can be found at point1nav.com/contact-us. So please feel free to ask any questions there or reach out, and someone with really deep technical expertise and precision location will get back to you. But otherwise, I want to thank you all for joining us today. Thank you, Max, Gabe, and David for that as well. And really looking forward to seeing what you create with centimeter level accuracy.
Thank you all.
Thank you all.
Thanks.
Bye. Bye-bye.